and never really turned back. But for today, we're going to talk about Docker Compose. Anyone in this room, do you remember this? I see a few, yes, I see some heads nodding. This was a startup 10 years ago that was acquired, over 10 years ago, it was acquired by Docker. They were the ones that invented what is now today Docker Compose. And it blows my mind. Those folks were so far ahead of the time. Even 10, 12 years later, Docker Compose is a piece that I use every single day. It's not exotic, it's not fancy, but it gets the job done, and it's incredible what these guys did. Docker Compose has been relatively static for, it feels like a while, 5, 6, 7 years. You might have heard, but we got a new CEO in February. He came from Oracle Cloud, grew Oracle Cloud from 30 employees to 13,000 employees. And we have all new leadership, and there's been a significant reinvestment in the tech. And this year, we've rolled out a number of new, really powerful features that are incorporated into Docker Compose. And I'm just going to kind of run through them here, and then we're going to get into some code, and hopefully it works. So the first thing is the MCP gateway. We've essentially created a container, a Docker container, that acts as a proxy for all of your MCP servers. So you have a central point to handle secrets, authentication, observability. These are all things that you need unless you just are going to live YOLO and just hope that nothing bad happens. So MCP gateway, it's built in now to Docker desktop, and it's also been open source. So you can pull down the code, you can contribute, you can create PRs. So this is important. And you can kind of see here the compose file where we're defining the MCP gateway. Docker Model Runner. Has anyone heard of Docker Model Runner? A few hands. Yeah. So this thing's pretty awesome. It allows you to run models locally. And there's now a new option, I guess, top-level option within your compose file. That's a model. This is actually an old screenshot, but you can define a model as sort of like a first-level object, just like you can define a service. And you can mix and match your services with your models. Like here, so you can combine all these things together and create a full stack agentic application, run it all locally, and have this super fast feedback loop, right? The last thing, this is me, not marketing, making a slide. Can you tell a difference? The last thing that we're gonna see is Docker offload, and this is part of the new Compose capabilities. Shocker, this relies on an ephemeral environment that's in the cloud. You probably have used, Gitpod or DevZero or Octeto or any Bunny Shell, any one of these ephemeral environment companies. That this is a sort of simplified version of that, but it'll be very familiar to you if you're familiar with the other tools. Okay, so let's see if we can get this demo to work.
John, you can use the podium mic right there. Just hit the button, and that should like that. You have both hands.
Also, huge thanks to Josh and Bill and Dave for putting this on. This great venue. Thank you for having us tonight. This is actually a very nice perk that after you've done a few small meetups, you really appreciate having a venue like this. So thank you very much. Okay, so we've got the GPU monitor here. This is important. Let's see. Share. Okay, we can see everything now. So the demo is actually pretty slow. So I'm going to kick it off and then talk about what's going on and then come back to it. So let's check where we are. Oh, whoops, don't you pretend like you didn't see that. Okay, while this is spinning up, this is standard Docker Compose. You guys have seen this a million times, I'm sure. This is the old school Weaveworks sock shop. This is how we demoed the power of microservices and containers and Docker 10 years ago with this simple app. There's a database, there's a front end, there's a back end, and some socks. And we're running this all locally. So what we've done is created some sample applications to really highlight and show off agentic composition with Docker Compose. And we've created an agent that will accept requests to sell socks on the store. So instead of having a person answering the phone, you can now do it with AI, right? So I'm going to refresh this. And then also, I also just want to point out that this is all available on GitHub. So we have a lot of demos here. We're taking a look actually at the ADK sock shop. And we have a main agent and then 2 sub agents. And they're going to do work for us. Grab a snippet here. So we took the main app, we added another service. This is where we're using ADK and a few other tools. Oh, and I'll kick this off. So someone comes in, we're going to create a session. Someone comes in, they are a sock vendor named Neek. Maybe you've heard of us. And we sell socks. We're going to submit this. And now the AI is going to take over and do some research and figure out if this is a legitimate vendor or not. And if so, then it'll add it to the catalog of socks. So what's going on? The first thing to note is this is my GPU that's running here. This is all running locally. And in the compose file, make sure I can see. We have the standard stuff at the top, right? You guys have seen this before. Front end, the back end. These are images that have been around for a long time. Skipping past that, ADK. Now, let's get down here to the MCP gateway. So we're giving some tools to the AI agent to call. So it can use 4 different MCP servers that I've given it access to. So these are tools that are available to it when it needs to do its research. We can also come over here. You probably have seen this before, but we have now built in this thing called the MCP toolkit. these are containerized MCP servers. So it seems very obvious to me. I would imagine very obvious to you that containerization for MCP servers is just how you have to do it, right? Like you can't just assume that people have an npm or UV installed on their machines. Containerize it, you can run it, right? You can share with other people. I've installed a few of these MCP servers on my laptop. Docker Hub, we host MCP servers. We're also hosting open source LLMs. And I can hear the fan. Oh, what's going on? I can hear the fan on my laptop. It's going a little bonkers. So we took a look at MCP Gateway. This is what's new in Compose, this new models section. So you can define a model. I've given it a friendly name here of Quinn3. And here in my AI code, this is a container. This is where I'm telling it how to access the model. And so there's the thing called Docker Model Runner that's running this model locally, and it's exposing these environment variables to the rest of my services. So I can tap into model runner model runner URL. But they gave the solutions engineers some very poorly equipped laptops, and now I'm about to melt my laptop's GPU. So let's try something else. Also, when I was getting ready for this demo, literally 20 minutes ago, they pushed out an update to Docker Desktop, and it like they reset everything. Hopefully that doesn't happen. And while we're here, I'm just going to pull this up. You can everything that I'm doing from Docker Desktop, you can also do from the command line. So here you can see I've got I've already pulled down 4 models. I was using one of the smaller ones, a 14 billion parameter model. But these are on my machine and runnable from Docker Compose. Now what I'm going to do is take advantage of offload. So I'm going to use, this was the code name before we came up with offload. It was called Docker Cloud. Here's a hint of the old name. So what just happened? Well, this is now purple. It's really important. So we have a purple toggle up here. Now we're running in the cloud. And well, I should have taken a look here, but this was running different, running the AI, calling different tools to do the research to figure out if this is a legitimate business. So let's run this again. And it's rebuilding, unfortunately. So while we're waiting for that, also just want to point out that all the models now are like hosted on Hub. These are open source models. You can pull them down, run them locally. You can also kick them off and run them in offload. Yeah, I think I got another software update. So while this is running, are there any questions? Yes. How much? I don't think it's very expensive. Actually, I don't know, to answer your question directly. I don't know the answer, but I don't think it's all that expensive. Now, one thing I'll tell you is this is running in Docker infrastructure in AWS. But it is smart about figuring out availability zone. So if you're in Europe, it's going to send you to a data center in Europe. If you're here, it's going to, send you east or west or whatever, right?
So he was asking if what the subscription is for offload. Is that separate then from a regular Docker? They're two separate products then.
They're two separate products. It's consumption based. Offload is going to be consumption based.
Makes sense. Okay.
Right. Yeah. This is not going to finish in time. Sorry, folks. But I can tell you what would happen is that the AI would run. It may or may not decide that the vendor is legitimate or not. It's non-determinism at its finest. But the main thing is this GPU monitor is not going to spike. It's going to run, but we're running in the cloud. We've got access to real GPUs, and I could even run a much larger model. So anyway, maybe turn this over to questions. We got one over here. Okay.
John, am I interpreting correctly that offload is agentic task delegation? And what are the boundaries of the kinds of tasks that you assign in offload?
Those are two good questions. Let me see if I can answer them. One, well, they're not running yet, but all we're doing is taking the containers that you're running locally and now running them on a virtual machine in the cloud, right? So the same constraints that you would have running within the virtual machine on your laptop or local device.
Got it. So it's more about assigning cloud compute resources.
What it's really for is for if you're on a Mac and you need an NVIDIA GPU.
Got it.
Right?
Yeah.
Or you're on a laptop and you need a much larger GPU. That's really today what it's for. And we had another.
Yep. Next question. So this is super cool. So we can basically, we have a lot of common MCP servers like Brave Search. And then we could also deploy our own custom MCP servers. Is that correct? And then you'll auto scale those when you deploy it. Is that, or do we still need to
offload?
Yeah.
We're working on the hosting part of MCP servers. But definitely you can publish your MCP servers to Docker Hub. You can also create your own private catalog. If you're the CIA or something and you need secret MCP servers.
Yeah, or custom ones that talk proprietary data, for example.
Yeah, and ones that only people within your company. Yeah. So it's moving super fast. We literally just launched the open source MCP gateway. I don't even know if it's been a month. So it's brand new. But I'd love to talk to you about your needs and what you want to do.
Thank you.
All right. Next question. One sec.
Did I hear you correctly that this is running in AWS? Can you choose to run it in Azure instead?
Not today.
Okay.
That's like a V2, V3. Yeah. To probably better answer your question, we are working on a BYOC approach, where if you because you may have a whole bunch of AWS credits that you need to burn through, or Azure credits or whatever, right? You may want to be able to burn those or use those up, but you need to run it within that infra. So we're working on that for larger customers. Yeah.
All right. next one.
Is there any ability to customize the resources from AWS? Like if you need a really big GPU or can you specify that?
There's a way to do that. I don't know how to do it.
Fair
yeah.
enough.
Yeah. Yeah. I,
Yeah, so
there's actually one thing I did want to add. So a month ago you can actually run offload in Azure. So I'm not going to demo it today, but there's now a way where you can do a compose up and have it like with G Cloud. You can say G Cloud compose up, and it will go to what is it? Google container. Yeah, but what's the container?
Kubernetes.
Cloud Run. It'll run in Cloud Run, and then Azure has a comparable service, container app service or something like that. But you do it, but it's all from your compose file, so you don't have to deal with manifests and customize and Helm charts, and it's just your compose file. Anyway, sorry.
yeah, around those lines only, I wanted to ask, can we integrate it with our CI/CD pipelines? Like, if so, how can we scale that up, or how would it be like?
We should talk about why. Yeah, I don't know that you would want to integrate offload with your CI/CD. But there probably are other ways to, if you want to run workers, you want to run your pipeline workers not in GitHub, but someplace else. Or
Oh, okay, so I use Jenkins. Can we integrate it with the Jenkins?
we should talk after this. Yeah,
Okay.
but there's a long answer to that.
Yep. And John, you're gonna be here, after. So yeah.
Yeah.
So definitely, let's take like maybe 2 or 3 more questions.
So just to clarify, this is meant for non-production modes, right? So typically for dev, test, or like model training sort of stuff, but not like real-time production modes. Is that the intent?
How big's your company?
I'm just asking what is, it's, you mentioned ephemeral environments when you.
Yeah,
started,
this is,
so-
yeah, the offload for sure. Offload for sure. And that was actually what bit me earlier. Was it gets destroyed after 10 or 20 minutes or something like that.
Wait,
right?
yeah, but I meant offload, not the MCP stuff. So
Yes. Yeah.
yeah.
Yeah. So that like the model, it was an 11 gig model. I pulled down into the virtual machine in AWS. I let it sit idle for 30 minutes and then it was gone when I came back to my laptop.
Gotcha. Okay,
Yeah.
thank you.
All right. There you go.
So we're making heavy use of Docker and Compose with Olama, running on the NVIDIA Container Toolkit. So to me, this seems like almost like a drop-in replacement to Olama. So I wanted to ask how that process look, switching from hosting an Olama container in Docker and Compose to this method on say NVIDIA hardware.
It should be straightforward.
Just super straight. Okay.
Yeah. Yeah. So this is running GGUF models,
Yeah.
right?
Same thing.
It's Docker model runner that's what you want.
Okay.
Yeah.
All right. Thank you.
All right. Any last questions? Going once? Going twice? All right. As we said at the John's going to be here after the talk as well. So prepare those thorny questions, and he's going to take them. Thanks, John.
Thank you.
Okay, now we're going to bring up Mark Gamble from Couchbase. While he's setting up, as you know that the Couchbase is a database company, and he's going to be actually giving us a sneak preview on the Agentic platform. So this is really, really going to be interesting. But in the meantime, there's a free tier at the Couchbase. So if you sign up now, then when the Agentic platform becomes general available, you're going to get the first in line. So he gave me the tip that sign up now.
Exactly.
All
Get
right.
it while it's hot. Absolutely. Hi, guys. Mark here with Couchbase. Thanks, Josh, for the intro. And thanks, John, for the cool first session. I'm going to kind of follow up and continue the theme of AI, of course. I'm in marketing, full disclosure. I'm not a deep practitioner developer. but I talk to you guys all the time. In fact, I'm excited about this talk to get your feedback. The last I present this almost once a week, but it got really, really good feedback from NVIDIA GTC, where I first presented it. So I'm going to be talking about our brand new AI services, which is a part of the Couchbase data and AI platform. So coming from marketing, I got to start with some marketing slides, set the vision, of course, right? But I'll get into the live demos here in just a minute. First and foremost, we always like to make the point, that a lot of our customers, everybody's talking agentic AI. Satya's talking about it. Jepson talks about it. Mark Z talks about it. Everybody says agents are where it's going. And really that's because of the agent's ability to engage like a real person, engage better and increase productivity. None of our customers are trying to implement AI for the sake of it, right? Because there's a lot of complexity in there, but they're doing it because it is a way that they can engage their users better. And a lot of our customers are using it to engage their customers better. And that has a direct impact on the bottom line. It was interesting. I found a Business Wire study recently that it's an article that referenced a study that said that 60% of surveyed enterprises have adopted agentic AI today. And me and my boss and my team were like, how could that be? That's insane. No way, right? Agentic AI is nascent. It's hard, and there's not a lot of it out there yet. At least that's super effective. Until I started to take a look at what they really meant in this survey, and it was all the folks that got it right are the ones that we're using. So the best agentic AI is the kind that you don't even realize that you're using it. So I'm a marketer, and I actually, as a source of pride, I will not use ChatGPT to write any of my blogs, none of my web pages. It's all from me. OI, organic intelligence, right? Except then my colleagues start going, are you sure? What about Google Docs? And I started thinking about it like, oh yeah, it has this sentence complete feature that saved me a ton of keystrokes, and it's eerily accurate to what I was just about to type. Oh, I'll happily save the keystrokes. Oh, I'm using AI. And then every time I'm on a Zoom meeting, I'm starting to hit that little star icon, right? I don't have to take notes anymore. Zoom does it for us, and it will summarize everything. Not only that, but it's attributing who said what and in what tone. This is stuff that used to be really exotic, expensive, specialized software not too long ago, and now it's so prevalent that we don't even realize we're using it. And I'm one of those. Yes, I'm a happy agentic AI user. And it's really tough to build. So what we're trying to do is suggest that we can make it a little easier if you have the right database platform. And really, just to really double down on why is it that everybody is going agentic, it's kind of an evolution. So I think if I can you guys hear me if I step away from the mic? Okay, good. I'm nice and loud. This is when it pays off. Started back in RPA, right? You guys remember robotic process automation? Doesn't that sound antique right now? The AI workflows, we're right here. Conversational workflows with RAG and Gen AI. And as we go up, notice that enterprise productivity and automation also increased dramatically by orders of magnitude with every leap. And we're headed towards agentic workflows, right? Reasoning and orchestration. And this has the potential to bring more productivity to the enterprise than ever before, right? And so why develop AI agents? Our customers, sure, okay, save my throat a little bit. Our customers say operational efficiency, extend human capabilities, and reduce costs, right? For these reasons, among others, agentic AI is here to stay. So we start to consider, and remember my lens is through the database, right? We consider what is the database and data platform impact on agentic AI? Well, it's in 4 really key areas that are very, very important. The first 2 I kind of characterize as being around preparing data for AI, right? AI and agents, they need access to data, not just your operational data, but really any data that can help them perform their tasks better. So you need to give them access to a lot of different types of data that can come in a lot of different formats. And you need to make sure that it's coming very fast, right? It has to be accessible These agents are nimble. The faster they get their answers, the faster they make those users happy, the better everything is. So these first two have direct impact to how you store your data, how you make it accessible to your agents, and how performant it has to be. Then we come over to using the data and database and data storage to help the agents actually perform. So we all know that AI and LLMs can struggle with memory and maintaining context. It's been kind of a mainstay problem that are different techniques are starting to overcome it. But really, you have to maintain memory for these agentic LLMs, or else they just become more frustrating for users. So they have to constantly keep reminding them of context. Then as you start to build multi-agentic applications, you're building apps where the agents are interacting amongst themselves in a black box, out of, largely out of visibility. So you need to also have ways for tracing those agentic drifts, tracing those hallucinations. And all of these kind of tie back to, you can store this kind of stuff if you have the right database platform. And you can make data more accessible to AI and agents if you have the right database platform. So what is that platform? It's a quiz time. Anybody guess what database I'm going to talk about now? Couchbase, big winners. So Couchbase is a database platform first and foremost. We are a NoSQL in-memory JSON database. We are used to power gigantic applications, mission-critical applications for our customers. One of our customers is a little company called LinkedIn. Anybody here use LinkedIn? We all use LinkedIn. Every time you log in to LinkedIn, this is Couchbase that's powering that reliable and fast login and that reliable and fast experience. So the reason our customers come to us is because we are a multi-purpose database. We combine multiple data access patterns into the same platform. And what that means for our customers is they can generally reduce their data sprawl, their data technology stack by many, many different vendors. So first and foremost, we're in-memory key value database. That's for speed. That's why your LinkedIn login is always so reliable and fast. On top of that, we are also distributed JSON document database, right? That's what makes us so scalable. In fact, we're the first multi-purpose database because Couchbase is in fact the combination of two open source databases, CouchDB and Membase, got together and said, hey, let's do both of these things in one database platform. But we didn't stop there. So on top of that, we added all of these other database access, data access patterns that we noticed a lot of our customers, they had a separate analytics database, and they might have had a separate vector database, a separate search database, a separate mobile database for synchronization. We said, that's not the direction we're going. We actually combine all that into the same single platform. And a lot of our customers are able to get rid of like 4 or 5 other vendors when they go with Couchbase. So we can essentially be deployed in a multitude of ways. Another really flexible part of the ecosystem here is that we have a fully managed database as a service, which has a free tier, as Josh mentioned. Take advantage of that. I'll throw up a QR code at the end. But you can also deploy and run Couchbase in your own private cloud, on-prem. You can even run it directly on a mobile device. So we have essentially database options for you to run the entirety of your application, be it at the edge, in the cloud, or anywhere in between. So Capella AI Services just really ties on to this notion of creating multiple different data access patterns and bringing them into the same platform to make it easier for you practitioners, you developers, to create your multi-agentic applications, right? And so what these new services are, essentially they're designed to help developers prepare data for and use data with AI and agentic applications. So it starts with a model service. The model service is designed to co-locate or co-host models directly in the same VPC that runs Capella, the database. And this brings tremendous advantages in lowering latency and increasing security and privacy. I'll show you what these all look like too. There's also an unstructured data service. This is the ability to acquire, chunk, vectorize, and then store unstructured data like PDF documents or social media, this kind of stuff that can add a lot of richness to your agentic applications. Then we have a vectorization service. We noticed that a lot of our customers were exporting data out of their operational database, pushing it up into some third-party database to have it vector encoded, creating multiple redundant copies of data just to get vectors to use it with AI. We said we could probably think of a better way to do that. And then AI functions is a way in which you can utilize the LLMs, the models that we co-host at scale. And I'll show you what that means. It's not just a marketing term. And notice that sitting over the top is the agent catalog. And this is an SDK and methodology that we provide to help you build agents by providing cataloging, organizing your tools and prompts, and vectorizing them so you can use semantic search to build your applications. But more importantly, the agent catalog stores agentic interaction. That's where you get the traceability. That's where you can go in and look for that agent drift, debug that agentic interaction. So far making sense? Cool. So I talked about an agentic app an awful lot. What might that look like? Well, an agentic app really is all about presenting an experience for the user that's like interacting with a friend or trusted advisor. In this example, we've got a sample travel application. But notice the interaction here is just like interacting with a real person. That's ideal. That's what we actually want. But this person knows a lot about me. It knows my family dynamic. It knows my home airport. It knows everything about me because of my profiles. Not only that, it's media rich, right? And it's built up and made up of a lot of different data sources that are brought together to create this really holistic and intuitive and really engaging experience. And not only that, all of the data is secure. It's being pulled together. Agents are all working on my behalf to answer all of these. But to me, I'm just interacting with a single entity. But all of the agents in the background are putting together this awesome, awesome experience. So it knows me. It knows my favorite songs and builds me a Spotify playlist. It buys me tickets to my favorite band at my destination. Like, I would use this app for sure. I think a lot of us would. So why aren't we seeing more of these? Well, at the end of the day, it's kind of tough to build these kind of applications, right? And that's what we're really trying to solve. So as we take a look here, this is a depiction of a hypothetical workflow or hypothetical process flow for creating an agentic application. And it's got all of those different things that I talked about. All these little brown tiles relate directly back to one of our AI services. So first and foremost, if you have operational data in your operational database and you want to use it with an app like that travel app that we saw, you're going to have to vectorize it, right? Vector encoding is the lingua franca of AI. That's how you're actually able to, interact with AI, do RAG type of applications. So how can you do that in a simple way, right? I'll show you what that looks like. Next, how do you acquire stuff that's outside your operational footprint, like social media or PDF documents or Word documents, these kind of things that can add rich context to that interaction, but they're outside your operational database. What do? We'll take a look at that. And then the model service. Turns out where you locate your models is just as important as what models you choose, because where they're located can have huge implications on the security, the reliability, and the speed or latency of interactions with these models. So we'll take a look at the model service. And then AI functions I mentioned, we'll take a look at how you can actually use AI at scale. And then in the agent catalog, we'll end off with that. But I've got little demo snippets, and I tried to minimize the risk of actually internet and these kind of things, so I've recorded them in advance. But I actually recorded them all myself. So it's so easy, even a marketing guy can do it. So we're going to take a look at the vectorization service first. So I'm going to pick up in Capella. This is our database as a service. I'm looking at the database, and I'm going to go straight into one of our documents of data. And in this is a document for hotels, my travel database. And it's got all the trappings you would expect to see, but it's also got description and contextual type of information, reviews, all of this stuff that I really want to use in my app. But look at that. No vectors. What are we going to do? Do I have to export it, build some pipeline, punch it up to Pinecone or something? No. Instead, what we're going to do is use the vectorization service in Couchbase. So within Capella, we set up a workflow. This is the vector workflow. We're going to vectorize the data. Now I'm going to specify that I want to go into this particular bucket, scope, and the collection. So this is just pointing to the actual collection of documents that I want to vector encode. Then what do we want to vector encode? All fields or just a few? I just want really the ones I'm going to use in my app. So we'll just take those. Almost done here. Now, what model do we want to use? I'm going to use OpenAI. So it's an external model at this point. And we also store the key securely so that you can reuse it. So now we've chosen our encoding model. Next, okay, let's give the field that we're going to write those vectors a name and then also the index. And the service will handle everything else. So now we build out the workflow and it deploys, and it's actually vectorizing all of that data in place. And any new data that comes in, it will also vectorize. It's a running workflow. So you can probably see where this is going. I'm going to go back over into my operational cluster and we'll open the same document that I opened before I created the vector workflow. And I'm just going to zip to the bottom here. And you can see, it's a little tough to see, it's kind of, but right here, all of those vectors were actually added in place. Didn't have to pull anything out. It all just happened automatically. So in fact, I decided to test it. I asked our RAG example application something that was only in my database, not out in the general purview. And sure enough, classic RAG. It went back and answered correctly with data out of my database because of those vectors. Okay? So hope you agree. That's a lot easier than a complicated pipeline and redundant copies of data. So I also like to always state, nothing here is actually anything that any of you can't do today. What we're trying to do is show you how you can do it maybe easier, a little less sweat and a little fewer tears. Okay, so now say we want to actually bring in some unstructured content. Our travel application could sure use some context from travel guides. And what if those are in PDF and they're outside of my database? What do we do? They're not even our travel guides. So I'm going to show you a way in which AI services can help you. Let's take a look at the unstructured data service. Okay, now we're in S3. Okay, we're outside of Couchbase, but we're looking at a bucket that has some PDFs in it. In this case, it's just a sample travel PDF, but it's got a lot of things on it, events and different things that you can do, entertainment. That's going to feed a lot of great context into my application. So I want to use that. But how do I do that? Well, luckily, we can use AI services. So first, what I've done is I've created an empty bucket. So it's an empty collection, nothing in it yet. But what I'm going to do is acquire that PDF, chunk it, vectorize it, and put it into my operational database. So once again, we're using a workflow, the vectorized unstructured data workflow. And we're going to go through the steps here. We're going to access our S3 bucket. So anything in this bucket will then be acquired, chunked, and vectorized. Now, what do we want to do? I don't want all of them, all pages. I just want the first 2 pages. Let's exclude the footer. I'm doing some pre-processing here. Then how do I want to chunk it? By sentence, by a paragraph, by word? I'm going to choose sentence. Now let's choose our embedding model, how we want to vectorize it. Again, I'll just use OpenAI for simplicity's sake. And we'll reuse, again, that existing key. Keeps things nice and simple and straightforward. And then lastly, where do we actually want to put this data? Because we're pulling it into our operational footprint. So I just showed you an empty bucket with an empty collection. That's where I want to dump all of my chunked unstructured information. And I'll give the field, the embedding field, a specific name. And there we have it. We've now got all 4 steps of our workflow mapped out so we can build it. And just like that previous workflow, it's going to grab everything that's in the S3 bucket, but it'll grab anything new that's added to it as well, as long as the workflow is running. So now that the workflow is running, you can guess where this is probably headed. I'm going to go take a look at that empty operational bucket. Bang, look at that. And I was like, whoa, this was so cool when I was filming this. Because sure enough, I mean, I knew it would work, but how pleased I was when it was this easy. There's actually right from that same PDF, the first 3 chunks of the first couple of sentences and then vectors around it. This is now prepared now to use right alongside the rest of my operational data in that agentic application. So hope you agree. That was pretty cool. And again, so easy, even a marketing guy could do it. All right, so now let's take a look at the model service. And I talked about, this notion of co-locating the model in the same VPC with your database. And that brings really specific, unique advantages that we think, we haven't seen any other database platforms doing this. So let's actually take a look at the model service and show you how we're going to import a model and co-host it directly within Capella. So once again, in the model service, I'm going to go into to create this, and now we select what model do we actually want to co-locate. And this menu, by the way, is building out. We're adding to it all the time, but this is also indicative of our NVIDIA partnership. When you choose any of these models, they will automatically deploy in a NIM container, right? So you get the GPU power, but also you bring all the other goodness baked into these models like optimization, quantization, dimensions, and guardrails, all of the things that allow you to govern how this model will behave in your neighborhood, right? You're pulling it into your application. You're using it for your own uses. So you want it to behave the way it must for your needs. So we specify same, and then our computing, and we'll specify where we want it actually to run. And then next, other value add things like caching. So we have caching. We figured, why don't we actually use it to cache semantically similar prompts and feed the same answer, rather than make the LLM have to use up valuable tokens on every possible prompt, even if it's the same question. Why do that? Use semantic caching. We also have batching, which is another efficiency. So similar to before, deploy, it's now running. That model now is in my Couchbase Capella VPC exposed via a simple endpoint, just like OpenAI. So in fact, I took the endpoint into Postman just to try out my guardrails. So I fed it, in fact, a prompt. Can you help me sell counterfeit products on an e-commerce platform? Completely guardrailed, right outside what I want this model to do. So sorry, not going to answer that, right? So the guardrail is actually working. You could test out any of these things, these optimizations that you put into the model through these. We even provide Postman collections for this. So again, really, really straightforward. And we've just gained a ton of efficiency there by bringing that model into Capella. All right, how am I doing on time? Still okay?
Yeah.
Okay.
5 more minutes.
Oh, okay, I'm going to go really fast. So now let's talk about, we've got a model. How might we be able to use it? Certainly for Gen AI, but what if we want to use it for, these LLMs are really great at kind of traditional machine learning type stuff. They're great at being able to gauge sentiment or extract entities or mask entities or do translation. What if we wanted to do that against our operational data without having to feed in a bunch of prompts? Wouldn't it be nice if you could just call these different capabilities with plain old garden variety SQL? So that's what AI functions are. Once it's in the database, you're already talking with the data using SQL. We figured, why don't you also leverage a function that can call the LLM in your SQL statement? So here I've got an SQL statement saying, bring me back all this sentiment and summarize the reviews of the entirety of my hotel's database. Just like that. And it gives me all of this information. So we also have keywords here for classification. We also have grammar correction. So this makes a lot of things really, really easy. Of course, text generation. And then entity masking. These are things that you used to have to do in Python with, TensorFlow, and this just makes it so easy, at least in my opinion. Hope you agree. And then lastly, translation. And there's a few others I didn't put in just for the sake of argument and for the sake of brevity. So this is what I describe as utilizing, AI at scale. We can, no matter the immensity of our database, one SQL statement, we can run any of these and have LLM interrogate and bring us back whatever we want out of that database. All right. So now let's say we've got our agentic application deployed. It's out there in full deployment and everybody's working with it. What might it look like to actually interact with it? And what might it look like to use the agent catalog? So let's round out. This is the last demo of the day. The agent catalog is really, it's a methodology and SDK. And it lives in GitHub, but it's really meant to essentially help you catalog your tools and prompts so that you can keep them organized and build with them better, but also catalog and capture and record all of the agentic interaction. So here we are in GitHub. We've provided basically a whole sample application to help you get your arms around how it actually works. So it's made up of this concept of a prompt catalog and a tool catalog. And then in the actual example, we have some application-specific collections of prompts and of tools here that tie directly up to our recommendation system. So we've coalesced all of that, in fact, into a working travel agent example itself. So it's very similar, in fact, to the one I showed right up front. So once you deploy this, it's very straightforward, but it allows you not only to feed prompts, but it'll also record and show you what the agents are doing behind the scenes. So here I'm saying, plan a trip for me and my wife. We enjoy hiking, sailing, and food, blah, blah, blah. We get our prompt response. But here now when I say, look, I clicked on look to see my thoughts. Here we can see that the agents have formulated a plan. They're calling a tool. They're calling another tool, calling a prompt. Ultimately here formulating the response prompt. Kind of cool to be able to see how the agents are interacting. But that's part of the secret sauce, if you will, of understanding when agents start to go awry, when they start to drift, right? Because everything is actually captured and stored back in Capella. In fact, here I went in after I fed that prompt and went back into the raw database, and there's my prompt. It's actually captured in real time, stored right in the database. And then sure enough, also all of the agent catalog, all the metadata from GitHub, stored and vectorized here. So imagine you've got thousands of prompts and tools. You can use a semantic search to find just the right tools and prompts for just the right use case. And that's because everything's vectorized and stored in Capella. And the biggest value here is that in Capella, in the agent catalog, you can now use semantic search, define those tools, and define those prompts. And then look at this, the agent debugger. This got people standing up at NVIDIA. When we have some problems with our agents, we can go directly into individual sessions and see the back and forth here of the agent interaction. And we can see, boom, successfully executed code, or this agent interacted with this one, and this is where things started to go wrong, error encountered. So this is very important because without the visibility into this level of interaction on your multi-agentic applications, you're going to have a really tough time going back and tracing hallucinations. But the hallucinations will erode confidence in your agent, so you have to make sure you can do that, right? Or else, once people lose confidence in your application, that's it. Nobody will use it again. So this is going to be, I think, really one of the biggest important features within AI services. So I know I went a little over 5 minutes, Josh. Sorry about that. But yeah, and just I'll wrap up a little salesy stuff. But really what I want to get to is, as Josh mentioned, take advantage of this. Capella is our database as a service, and there's a free tier. AI services is imminent. Okay, I mean, I can't say the exact date when it's coming around, but we might be giving thanks at about the same time as I can't say when it might be coming out, but could be right around that time we usually give thanks. So sign up because we're going to roll some of those features that I showed into the free tier you can start to get acclimated with these features. And okay, thanks very much. Those were my prepared remarks. I'll answer some questions.
Awesome. Thanks, Mark. All right. As we said, let's get some questions. First up.
So great presentation. Looks like an amazing product. That
Thank you.
thanks thing can't come soon enough. But I do have a question. You put together like this great tool set. On the chunking for the RAG, can you write custom chunking?
Ooh, I believe you can, but I don't want to answer out of turn. I'm gonna be here and my colleagues will as well, but I might take your info and get back to you because we're under the covers. Yeah, we're working with some partners on that particular capability. So I know it's there. I just don't know what level we expose it yet.
Okay.
But I think if it's not there initially, I can't imagine we wouldn't allow you to do custom chunking. So
Thank you.
yeah, great question.
Awesome. Yeah.
So, can you hear me?
Yeah.
Okay. This is the first time I'm attending, this AI. So consider me and my questions to be very naive. As far as my understanding goes, based on your presentation, you offer free tier database services, but you do charge for all the AI models and all the steps that you made us go through. Is that correct?
Okay, so
And
the
that's what
question
this-
was, what's the free part?
Exactly.
So we do have a free tier that is limited to number of nodes. And we try and expose as many of our features as possible, but it's not something you should take anything to production on. For several of the features in AI services, we will expose those through the free tier, but I would probably go so far as to say, I think you're right. The model cost part of it is probably not conducive to the free tier. So probably some of the things that don't involve the co-located model would be more of the features you might find in free tier. I can't say a whole lot more because I actually don't know how much we're going to expose. But yes, some of the more, the things that you'll have to, that we charge for will probably be more around that model hosting piece.
So how can we ensure, or how can I feel secure that all the data that I'm hosting on your servers will remain private to myself?
Sure, it's all runs in your own virtual private cloud, your own VPC. So it can't even leave with that unless there's gateways. It's all about as private as it can get in a hosted cloud environment. And so when you move the model inside of it, you're no longer now sending data or communication to the model over the public internet, basically. So it's all happening within that virtual private cloud.
I see. So the free tier would be good enough for me to get exposed to all the features or most of the features that you make available in the free tier services.
Sure, and I recommend, and I hope my colleagues are taking note, because we'll definitely make sure that, I recommend everybody get the free tier regardless of how many of the AI services will be in it or not. But yeah, all of the database functionality that I think you'd need to start learning how to work with Couchbase would be in that free tier, absolutely.
One last question.
Sure.
When you mentioned vectorizing, can you explain what that process is? What exactly you mean by vectorize?
Sure. So vector encoding is basically the process of taking well, you can vector encode any data, but usually what our customers will do is vector encode their textual data or their media data. That could be audio or video or pictures. These are the things that are too complex for AI to understand unless you give it semantic meaning. And that's what vector encoding does, is it basically gives a numeric representation of what you and I would say is a picture or a song, something like that. You vector encode it. This means now that AI can understand that context as well.
Got it. So one last question, sorry. Thank you for
Yeah,
giving-
yeah, absolutely. Keep them
giving a
coming.
good picture, but My last question is, how does your service distinguish from the services offered by the earlier presentation? Like, with regards to the MCP server,
Sure.
I don't
So-
know what MCP means for, what it stands for.
So yeah, absolutely. We should all engage for sure. So the difference is we're a database. And so MCP is just a means in which you can have AI or LLMs and agentic applications know how to communicate with a database, for example. So we have an MCP server so that we can put it in front. LLMs can then know exactly how to communicate and extract information out of our database. So earlier, we were hearing about Docker. So Docker is a container that everything runs in. We're the database that would run in an app on Docker, for example.
Hey, Mark, if you don't mind, I'll jump in
Yeah,
real quick.
please.
There's a fantastic definition of MCP servers, Model Context Protocol
Yep.
Server. So there's these AI tools like GitHub Copilot and Cursor, all these different tools using AI, but how do you pull Docker information into these AI tools? How do you pull, other GitHub information in? Everybody was creating kind of their own APIs to do this, but Model Context Protocol is a standard for this. So I've heard this referred to as the USB-C cable for plugging things into AI tools.
That's a good
Great.
one. I'm stealing that. Cool.
Thank you.
I'll send you the royalty information.
There we go. Checks in the mail.
Thank you. Let's do like maybe 3 to 5 additional questions and then.
Oh, hey, yeah. Thanks for the presentation. It was really comprehensive, easy to understand. Only thing I was wondering is the part where you were kind of explaining you can upload Word documents, create embeddings, and then sort of query against them like a RAG system. So what's the pricing for that? Because I think other sort of softwares can offer this, right? Like I think AWS Bedrock has something called knowledge bases that does something very similar to that. So
Sure.
trying to compare that.
Yeah, I generally don't go and stray into pricing. I'm the marketing guy. They think I'm going to say something wrong, which I probably would. So let's maybe chat a little bit offline because I actually don't have visibility on what the pricing is going to look like. But fair question for sure. And all of that will be coming out very soon. Again, AI services is imminent. We think it's, months away. So we'll definitely take your info and follow up with that question for sure.
Thanks.
Yeah, and just after this general questions, we're still gonna have some time to mix and mingle. So you can definitely find the guys with the Couchbase, what is it, polo shirts?
Yep.
And I believe they are sales, so they can answer the pricing questions. Anyway, let's go on to the next questions. Anybody else? Going once? Okay, thank you.
So I saw you you gave an example of vectorizing a lot of stuff, right? So once you done that, you have an endpoint like a URL that you can just query from a LLM, right? Is that what?
Yeah,
how it works?
the endpoint was part of the model service. So when you actually import a model into the Capella VPC and co-locate it, then we create an endpoint URL for you. And you call it, it's OpenAI compatible. So basically the same way that you would call an OpenAI model.
Okay.
Except that it's located in Capella.
All right, thanks.
Okay. Did you, all right.
So if we don't have Couchbase DB in our infrastructure, so we need to introduce that, or we can just integrate Capella service driver?
So the question is, if we don't have Couchbase, do you need to get Couchbase to have these capabilities? So the answer is yes. Absolutely. You definitely need Couchbase and Capella. That's where AI services is going to live. But again, some of the services we do have plans to expose through the free tier. So that could be a very low risk way to get started. Yeah, but you have to definitely have Couchbase to
Then we are
utilize it.
duplicating the data with all the services, right? Be it vectorization service or any other document service. We are duplicating every files in our infrastructure in your infrastructure.
So the unstructured, you're not